This is the new Titan extruder. I'm going to convert it from a 1.75 millimeter filament to a 2.85 millimeter filament. Now, you might be asking yourself, why would I do that? The only reason I would use 3 millimeter filament personally is for using Ninjaflex, because 1.75 millimeter filament Ninjaflex is just so flimsy. It's like wet noodle flimsy, and it's really hard to push. 3 millimeter filament is actually pretty rigid, and you can push it pretty well. You know, I can you may not be able to see this that well, but I can push on about like an inch. I can push that compression pretty hard before it buckles. Versus the 1.75 millimeter, I mean, you can't push that at all. It just wants to buckle right away. Like I'm not feeling any force or any resistance to buckling. The new Titan extruder, it's designed for the Hictop D3 Hero or the Tenlog D3 Pro IDEX independent dual extrusion printer. And this is an upgrade extruder from the normal one that comes with it. So here's what's inside. Got a little bag of parts and Allen wrench and a cable in case you need to switch the direction of the extruder motor and you don't want to switch the pins, and then the extruder itself. And that's all that comes in here. Now what I'm going to do with this one is I'm going to convert it from a 1.75 millimeter filament to a 2.85 millimeter filament. Why would I do that? 1.75 millimeter filament is so much easier to drive for the extruder motor into the heater block because there's much less pressure required to push it. Well, the only reason I would use 3 millimeter filament personally is for using Ninjaflex, because 1.75 millimeter filament Ninjaflex is just so flimsy. It's like wet noodle flimsy, and it's really hard to push. 3 millimeter filament is actually pretty rigid, and you can push it pretty well. You know, I can you may not be able to see this that well, but I can push on about like an inch. I can push that compression pretty hard before it buckles. Versus the 1.75 millimeter, I mean, you can't push that at all. It just wants to buckle right away. Like I'm not feeling any force or any resistance to buckling. I should say this is not 3 millimeter exactly. I think it's like 2.85 millimeter. And it's pretty rigid. So my first experience with Ninjaflex was in a Lulzbot mini printer. And Lulzbot by default uses 2.85 millimeter filament. And at the time I didn't really think much about it until I tried to print it in another printer that required 1.75 millimeter filament. And what I found out is that you just don't get the same quality extrusion from the 1.75 millimeter filament. It's inconsistent. You see the layer lines a lot better. I mean, the stuff that comes off the Lulzbot in Ninjaflex is amazing. It's like perfect. It just looks beautiful. Like the lines are all perfect. I did upgrade my Lulzbot a little bit to make the axes tighter and stuff like that, and that made a difference using bronze bushings instead of the plastic bushings they use. But still, it prints this stuff wonderfully, and I've used it for years like that. The only problem with it is it's not dual extrusion. And therefore, why would I want dual extrusion with a Ninjaflex? Well, I want to be able to print Ninjaflex with support material, with soluble support material, because Ninjaflex, if you use Ninjaflex as its own support material, it is impossible to remove. I mean, it's stuck on there. This stuff is so strong. You have to use nippers to cut it off, and an X-Acto knife, and even an X-Acto knife doesn't want to cut this stuff very well. So I just try to, anytime I design something out of Ninjaflex, I try to avoid having support material, and that limits the designs a lot. So I've discovered the soluble support material that I'm using right now, which is Aquatech X1, and I think it's made by 3D Tech, I believe. And that stuff, it printed really well, and you just put it in hot water and it dissolves away overnight or within a few hours. It was amazing stuff, and it made this, I made a Ninjaflex print using this 1.75 millimeter filament that I would not have been possible to do with a single extrusion printer because of the required support. The extrusion of the Ninjaflex wasn't great, so what I want to do now is take this extruder from Hictop and modify it to accept 3mm filament, because it's a Titan extruder copy, and Titan extruders are known for their ability to run either 1.75 or 2.85mm filament. And the way they can do this is they have a Teflon tube that lines most of the distance of the inside of the extruder. So theoretically, all you have to do is swap out the Teflon tube with a Teflon tube that has a different diameter. So right now this Teflon tube in here is sized for 1.75mm filament. If I swap it out for something that's sized for 2.85mm filament, which means the tube is probably 3mm, then I should be able to extrude 3mm filament without much changes, without much other changes. The only other thing I'm concerned about is how in line this entrance has to be here to properly extrude the filament, and can I get enough opening here between the bearing and the gear to fit the filament. And if not, what I will do is I will hob the gear a little bit, because this gear is a flat gear. I don't know why they did that exactly. I prefer something where it has a little bit of curvature and grabs the filament better, but it's a flat gear on there that grabs the filament, and I could hob that out by making a groove and then using like a tap to hob a gear in there that is curved to grab onto the filament and create more space. I can actually see all the way through here. That's interesting. Wow. If I look straight down this, I can see all the way down. It's cool. So now we're gonna start doing a teardown of this to replace the Teflon tube in there with this Teflon tube I purchased. And let me take a quick measurement of this tube. It should be, I'm hoping it's gonna be 4mm. Yes, it is 4mm. So I was able to find on Amazon this Teflon tube that has an OD of 4mm and an ID of 3mm. And yep, 4mm. So the theory was that the Ninjaflex should fit down in here, and it does. It's got a bit more resistance than I would have hoped for. So here's a problem I just ran into when I was trying to put this Ninjaflex into this 3mm ID Teflon tubing, is that I was under the assumption that everything that's called 3mm is actually 2.85mm, and that's the case with most rigid filaments, but this Ninjaflex is actually 3mm filament. It's marked here 3mm, although some places online you'll see it advertised as 2.85, but it clearly measures 3mm, and when I look at their website, they don't have 2.85 on their official website. They only have 3mm. So I'm measuring like 2.98, 2.96, 2.99, 2.98. I mean, it's right at 3mm. So if this is 3mm ID and this is 3mm OD, it's not gonna fit very well. So it just doesn't want to go in. It slides in, but you have to like push really hard. It's gonna be too much resistance for pulling in and out. A solution to that, since I can't readily find Teflon tubing that's gonna be fractions of a millimeter bigger than 3mm, ideally you want maybe, let's say if 2.85mm filament fits well in 3mm tubing, then you want like a 3.15mm tubing ID. So my thought was, well, maybe I can ream it out. And so I checked, and I found a reamer that's 3.17. So this is about the size that you want to make the clearance for the 3mm filament. Now, when you go to ream this filament, if you just try to ream it freehand, it's going to expand. It's going to expand on you. It's going to when you push the reamer in here, the reamer is just, I can see it bulging, it's expanding. So this is going to have to be supported when you're reaming it. And that means you're going to have to find something that has a 4mm hole in it that can support this, and then you can ream it, and then it won't allow the wall to expand, to bulge out while you're trying to ream it. I was lucky enough that I found this piece of extrusion that has a perfectly sized 4mm hole, and it has a slot so I could actually squeeze it a little bit in a vise to clamp down on the tubing even more. So you could actually build something like this. You could actually make something like this out of aluminum. You could get an aluminum block or a cylinder and drill a 4mm hole into it. I only needed about 2 inches. You could probably even do it shorter, and then you just ream in segments. I cut it about 2 inches long, and then you can put a slit in it to kind of like squeeze it together a little bit to really tighten it on there if it's not tight enough. So where mine is like tight where I can barely slip it in there, now I'm able to ream it, and it's actually removing quite a bit of material. And I'm gonna do it slowly and pull the chips back out. One thing you want to be careful about doing is not kinking the tubing like I just did. So now to test it, after reaming it, put the filament in there, and now the filament slides pretty smoothly and easily through there. So that's what's going to be needed to get the tubing to the right size for the filament. We're going to take this extruder apart now and remove the Teflon tubing that's in there so we can replace the Teflon tubing. So the fan shroud has to be removed. There's a screw down in here. You can see it there that I have to take out. And then it kind of snaps outwards like that. The LED is held in place in the fan shroud. Let's get this screw to fall out of here. Or stay in there, whatever. Now the next step is to loosen the heater block here from the heat sink. Something I need to make sure not to forget is to tighten these screws here, because on my past extruder they were both loose, although they seem actually to be relatively tight now. I don't know if that's just that they loosen up when they do the first cycles of heating and cooling or what, but these are tight. This is something I recommend anyone who buys this Titan heater upgrade to check right away that those are tight. Okay. Well, I'm going to take these screws all the way out. So the heater block is loose. Now I've got to press this to pull out the Teflon tube. I'm going to be able to measure this Teflon tube and make the other one the same length. So I'm curious as to how far that went up. Actually, did it go all? Looks like there's a stop at some point. It's not just hitting the gear. It's actually stopping before it gets there. This is the old Teflon tube, and I was just thinking you could actually use this fixture here, like I designed to remount the other one, to actually drill and remount this Teflon tube until it's the right size. But since I already have this other Teflon tube, that's the 4mm tubing, I'm going to use it first. What I'm going to do is measure the length of this, and actually just, when I say measure, I'm just going to cut it to length. Try to trim this square here. And cut this piece to length, to the same length. That's good. Round this out a little bit. Hopefully it rounds itself out in there. And I'm gonna have to ream this out on both ends. So I've already reamed out one end a little bit, and I'm gonna go ahead and ream out the other end of it. You have to be careful with this Teflon tubing. It's pretty soft at this thickness. Generating a surprising amount of heat. Now we can test to see how well it slides in there, and yeah, it's pretty smooth. I'm rotating it a little bit and doing it again because I noticed that it could be bulging into that crack a little bit, because that crack is really wide on mine. So there could be some spots where where it's bulging out, it's not reaming well. So it feels smoother as I do it again. Do it like one more time. Oops, there we go. I kinked it. It's really, push it in really carefully. Do the same thing with the other side. Do it a few more times just to make sure that it's been done properly. And push this in slowly. It's very, very tight. This tubing collapses easily. So I'm going to rotate it, do it another time. Okay, and pull it out if I can get it out. And rotate a little bit, do that again one more time. Okay, hopefully I didn't do any damage. And then this slides through easily. Yep. I'm going to need to tear down this extruder a little bit more. So the next thing is to remove this fan mount here. And just to recall, those are short screws also, kind of like the ones on the outside, the shell. Unplug these plugs right now. And then remove this plate that the circuit boards were mounted to, so I can access the Titan extruder. It's the only way to get to it. These are flat heads. Okay, so now we're at the extruder. Go ahead and take this off. This is going to split open here, and there's a spring in the nut there. Might spring out. There we go. Take this spring out for right now. I'll take this out here. So this is designed so that sometimes they can use a Bowden tube to go to the extruder. So right now the Teflon tube is going inside and butting up against the inside of this plastic piece. And inside of this plastic piece, I think, is sized to 2.74 millimeters. So not big enough for the 3 millimeter filament to pass through. So I'm going to ream this out also. Sometimes reamers can cut out holes close to the size, but this is too small. So I'm going to get it the right drill bit for that. So now I have a 3.05 millimeter drill bit, and so the first thing to do is to drill these out. And I'd already drilled it out before, I'm just using it as an example. And then this one too, over here, we've got to drill this out also. Again, I already drilled this out previously, but just using this as an example. So drill that out, be careful not to hit the bearing, because this was also sized for 1.75. And then you're going to ream those out afterwards. So take the reamer that we used previously, and ream these out to size. So now the filament should fit through these easily and smoothly. This one still honestly has a little bit more resistance than I would like. I may just get a slightly bigger drill bit and drill it out with that. Then when we put it back together to test, what I was concerned about is that I may have to like make a groove in the gear and hob it, because now it was designed for 1.75 millimeter filament, but now it's, let's say, you know, it's too much off center for the 3 millimeter filament. But the thing is, with Ninjaflex, Ninjaflex is flexible. So when the idler gear compresses it, it actually squishes it down where it's actually in line with the tube. So it seems to feed really well. And here you see it coming down the Teflon. It feeds no problem. And I can really push, I can apply quite a bit of force to extrude it out, and it's not buckling anywhere. One problem a lot of times with the 1.75 millimeter filament is that it'll buckle in here and get jammed and roll around the gear or the idler. So this 3 millimeter will help a lot with that. It's also a good time to completely tear down this Titan extruder, and you can see that here's the drive gear, or this is the stepper motor gear, brass gear. It's got a bearing on this, on the outside of this, that this rotates on. And then this is the filament drive gear. It's hobbed in terms of like there's teeth this way, but it's not like hobbed like the way we talk about where it's got the groove and the gears inside the groove. It's more just like gear teeth. And there's a bearing there too, the bearing there, and there's a bearing on the outer shell too on the top. So everything is supported, nicely supported with bearings in here. So here we're going to need to carefully trim some flash that was produced by the drilling process. So with an X-Acto knife, just trim that off. This piece actually came apart. I discovered that this is a little plug that goes in there, and it's probably so you can adapt between the different sizes of filaments. And so you could actually remove that and replace it with something else, and it makes it a little bit easier to work on when you do remove it. So I drilled it out just a little bit bigger, just so it would be easier to for the filament to slide in there. I'm going to trim the top edge a little bit. It's very thin, so I'm going to trim it until it gets a little bit thicker. Okay, now I can push it back in here to the same level where it was. It was just flush with the top, I think. There we go. And put this back there. And this should go right into it. Then put these pieces back in. Test it out again. Seems like everything's feeding fine. This will probably improve the retracts a lot too. All right. Looks like I can probably go ahead and put the heater block back on. It'll be a little bit easier so I don't have to stretch the wires out or kink the tubing. So this hopefully should just go in the same way it came out. There we go. Just something stopping it. So I'm going to pull this out. So one way to push it down all the way without kinking it is to put like a hex wrench, put something like a hex wrench in there, and just push slowly, get it to go in. Mainly it's into the bottom of the heater block. It's the difficult part, difficult area for it to go in. Looks like it feeds all the way down. Success. I did not feel any resistance. Okay, now I think if we as long as clean this out well, blow it out, then we can reassemble all this stuff. test before I put all the screws in. Does the filament fit? Okay, seems to feed. The pressure is all the way to the lowest setting. Could almost be lower a little bit. But it feeds. Feeds, it retracts. It's bottomed out. Here you can see the Teflon tube here, moving in there, feeding, retracting. This will work well. Let's keep reassembling this. Okay, now put this plate back on. Let's tighten up that heater block. Okay, this was dumb. I installed the heater block on the wrong way and it was touching the plastic and it melted the plastic on the fan shroud. I knew something was wrong earlier. It's late and I wasn't thinking clearly. Like, it's obviously it's touching the plastic. It's going to melt that plastic. So it's supposed to be rotated 90 degrees. So it should be rotated like this. So this is how it should be. So it's not touching contact in the fan shroud, obviously. That was a terrible idea. Okay, so make sure you assemble it correctly when you assemble it. Okay, this is ready to be set up on the printer now, and I think we just have to adjust the stuff in Cura or whatever slicer you use to tell it to use 3mm filament, so it just adjusts the flow rate. But the E step should be the same because it's just the distance that it's extruding that the actual filament is moving, not the stuff coming out. So should be good to go.